Hello, it's Keith here, and this is lesson 8 of the simple series of my 68,000 assembly tutorials. We're going to be looking at the Atari ST today, and we're going to extend the smiley example we saw before, and we're going to put some joystick reading controls in there. Let's go over to the code and let's learn all about it. Okay, so here's the Atari ST example. I'll just get to the top here, and let's just run this and see it in action. Here's the smiley, as you can see, and if I press the directions on my joystick, you can see the smiley moves around the screen, but it can't actually go off the screen. We've got some range checking to keep everything in control there. You can see we're reading in from the joystick just fine, and that's what we're going to learn about today. Now, the code we're going to be seeing today is based on the previous simple series examples, so if you don't understand some of it, we're going to skip over a little bit quickly. Please see the Hello World and the simple series for the details of how to build the file and things like that, and what the screen initialization does, because I really can't go over them all every single time. Now, the first part of the code here is enabling supervisor mode here. Then we're turning on the screen here and selecting the screen base. What we're doing next is we're defining the colors, and then we've got the first new command here, which is running this allow joysticks routine, and this is based on the code I used previously in the platform specific series. Here it is. Now, on the Atari ST, unfortunately, we can't directly read the joystick as we would possibly like to. What we can do, however, is we can insert an interrupt handler that the operating system will run as part of the interrupt, and that will get the joystick data. Now, to do this, we're having to turn on the joystick here and enable the reporting from the joystick. Then we're having to request, using traps here, the vector table for the interrupts from the hardware. Now, what we're doing here is we're just backing up the old version just in case we would need it later. We don't actually, but it's good practice. And then we are implanting our own interrupt handler into this vector table. And so whenever the joystick is being processed, we will get a execution of this routine here automatically. And what it's doing is it's storing 2 bytes from joystick 0 and joystick 1 into these 2 bytes here. The effect of this is actually, once we've done all this work at the start, that we just need to read from these 2 bytes to get the current status of the joystick, or the joysticks if we wished. So that's what we've got to do. So this has turned on the joystick handling routine for us, and from then on we're plain sailing really. We just need to process the input and work with it accordingly. Now, at the bottom here, you'll notice we've got a player position. These are 2 words for the X and Y position, and a second pair for the backup of the last valid position. A little bit further up here, we've got our smiley face sprite, and we've also got a blank sprite for removing the smiley face. This is basically almost exactly the same as the previous simple series on the bitmaps. Here is the 2 versions of the bitmap routine that have been modified. One shows the blank, which to remove, and one shows the smiley to draw the smiley to the screen. And you're going to see these in use during our main code, which is just here. So we're defining a starting position for our player here. And then we are loading a dummy value for the joystick routine, and we're skipping over the joystick reading routine. Now, during the normal execution, what we're doing is we're reading in from the joystick data, and we're waiting for a key to be pressed, but obviously we need to show the starting position, otherwise we'd never see the smiley to start with. Once we get to here, we are backing up the current position of the player. We're then removing the old sprite, and we're processing all 4 of the bits for the 4 directions of the joystick, and we're altering the player position accordingly. At this point, we're storing the new player position back into the variables there, and then we're going to check the position of the player. Now, the screen, of course, starts at 0, 0, and if you go below 0 in a 16-bit value, you'll roll back around to 65535. So we don't need to check if the player's position has gone below 0, we just need to check if it's gone over the limit of the maximum width and height of the screen, and we're doing that here. 40 wide, 200 minus 7 tall, that's the valid area of the screen in this case. And we are jumping to here if the screen position's okay. If it's not okay, we're restoring the old position from the backups we took earlier. So that will restore the player's position, and that stops them going off the screen. The last thing to do, draw the player back onto the screen, and then we've got a delay loop here just so that the code doesn't run too fast. Finally, we just jump back up here for the next repeat of this main loop. And that's all there is to it. So really, all of the work of actually reading the joystick is being done really mostly by the operating system. This is the getting the data from the operating system and storing it for later. And this is initializing the joystick handler here. So you can copy this code to your own program and it should work just fine. Actually, I don't know what that's doing there. Shouldn't be there. Anyway, that's all it takes, so hopefully this will be useful to you. If you want, you can go to my website and get the source code and the build scripts as well and give this a go. You're going to see this code again in a more advanced form later on, because I've actually made a little game from this example called YQuest. It was originally Z80, 6502, and now there's a 68,000 version, including the Atari ST, so you'll see it again. Anyway, if you like this though, please like and subscribe. Liking the videos encourages YouTube to recommend them to other people, which helps me out. And subscribing is a general morale booster so that I can justify doing more work on these videos, because it takes a lot of research, programming, and making the video and the website documentation as well. So please consider doing that. Anyway, whatever you do though, I wish you all the best with your programming, and I hope you enjoy the Atari ST. Thanks for watching today, and goodbye.